Welcome to the Grassroots Clean Tech Podcast. As the age of abundant renewable energy dawns, we amplify the voices of people building a bright future with their own hands. If you explore most cities, you can find fragments of a world that used to run on the muscle power of horses. You can spot buildings that used to be stables, or even the fountain in the town square that used to provide water to thirsty horses. This podcast is a search for similar fragments of the future instead of the past. A future that is not based on fossil fuel. But unlike those silent artifacts of the past, we get to talk to living people. I'm your host, Matt Weiner. We have a great interview lined up with Gabe Sira, an architect working with nature-based solutions for wetland restoration and coastal protection. This is called the Emerald Tutu project, a name that will make sense to Bostonians but leave others scratching their heads. Gabe will explain why the name is apt with some fascinating insight into the architectural history of Boston. Best of all, this project literally involves the roots of marsh grasses forming coastal defenses. You'll have to tune into the next podcast to see if I always take the grassroots thing quite that literally. But first, as always, a couple bits of news that aren't featured prominently enough in mainstream media. In the area of energy and tech, the United States Bureau of Land Management tried to lease the right to mine 167 million tons of coal on federal land in Wyoming, and failed. The Biden administration suspended leasing of this land. The Trump administration restarted it, and both decisions were met with a great deal of celebration by one side of the aisle and frustration on the other. But when it finally came time to bid on the right to mine this coal, there was only a single bidder, a Navajo-owned company who bid $186,000, less than a hundredth of a cent per ton. Worth noting that this is a location with developed infrastructure for mining. It would be essentially extending an existing strip mine with new ownership. The coal industry is very politically active, but they do not believe in their long-term future enough to invest in it. Their political activity is keeping their existing investments in production, but they are not planning a long-term future for the coal jobs they make so much noise about. The other bit of news that should have gotten much more attention is that on October 22nd of 2025, UN Secretary General Antonio Guterres said that one thing is already clear. We will not be able to contain global warming below 1.5 degrees in the next few years. Overshooting is now inevitable. Now, this won't surprise people who are paying attention, but it is important to remember why 1.5 degrees Celsius was the target. At the 2015 United Nations Council of Parties in Paris, a rough consensus was emerging to target 2 degrees of warming. But many island nations in the Pacific, led by Tuvalu and the Marshall Islands, formed a coalition to push for a more ambitious target, because warming above 1.5 degrees Celsius would lead to a very real risk that rising sea levels would wipe their nations off the map. Basically, 1.5 degrees was estimated to be the threshold at which sea level rise would probably become noticeable and destructive. And here we are, on the wrong side of that threshold. It isn't a situation any of us wanted to be in, but there still is action we can take. In some places, that may involve building seawalls of boulders or concrete, but nature-based defense is another strategy, where millions of marsh plants weave their roots together to build our defense. And weaving is exactly how the Emerald Tutu project builds their habitat for those plants. This was the way medieval Europeans built many things. The hedgerows that contained cattle were woven from living trees that were split and bent. The walls of farmhouses were woven from flexible trees like willow. And the roof was thatched, a form of weaving. People can build large and durable structures this way. Some of those hedgerows have stood since the Bronze Age. So now let's hear from Gabe about how some of these techniques can be applied to protect a coastal city from the unquiet ocean. Give us a quick elevator pitch explanation of the Emerald Tutu project and your place in it.
Yeah, I've been running this loose research group of affiliated academic researchers and activists and designers. Um, and I think, big picture, we've been trying to figure out how to use really simple local biomass um, and very simple protocols to develop new ways of regreening coastal landscapes.
Excellent. I'm fascinated in this both from a ecological perspective, coastal defense, and also sociology. So I think there's a lot to talk about. The first thing for non-Boston folks, explain why Emerald Tutu and talk about, I believe it's an emerald belt around Boston.
Oh, yes. So Frederick Law Olmsted, who's sort of credited with developing landscape architecture as we know it, um, had this. Well, he was like the Boston Park Commissioner, I think, or worked for the Parks Department in the city in the Victorian period, in like the 1890s or so. Um, this is the same designer who did Prospect Park in Brooklyn and Central Park in Manhattan and so many of other parks across the United States. Um, he had this idea for Boston called the Emerald Necklace, which was the interconnected park system. And so we thought that we would be a little more cheeky and fun and call it the Emerald Tutu as a sort of like external fringe around the city that would be a regreening of the outer edges that is more soft and porous and silly. Um, and I think a kind of final note on Olmsted is that what we call nature-based infrastructure was something that he very well understood. And the Emerald Necklace is not just a park system for public enjoyment, but has a bunch of different functions in the city. It's a piece of transit infrastructure. So there's public transit and roads that intertwine through it. And it's also stormwater infrastructure. So the idea of just using a park as a kind of a runoff device was really kind of his idea back then. And we call it nature-based infrastructure these days.
Uh, that's a fascinating connection. With rising sea levels and increasing storms, there's a lot of talk of coastal defense and people talk about coastal armoring. I love the idea of rather than armor, getting protection from a tutu and something beautiful, living, something that yields to the storms. Describe for the listeners the kind of structures you're building.
Sure. I mean, generally the theory is the more soft things you have between a wave source and something you're trying to protect, the more those waves get dampened down and calmed. And you can make an equivalent to an amount of marsh or planted matter or even just like porous, spongy other material, and make an equivalent between that and a hard seawall, for example, in terms of the amount of weight of wave energy that it can stop. But the key difference is that anything soft absorbs that energy and dissipates it rather than a hard wall, which will simply reflect it. And so reflected waves actually cause quite a lot of unintended consequences and damages elsewhere. So the goal of that kind of soft, spongy tutu like idea is that it's actually absorbing the waves.
And I'm guessing this is an excellent habitat for wildlife and possibly even commercially important fish.
Yes, exactly. I mean, the generally the three main co-benefits of nature-based infrastructure is there's water quality improvements. So, just removing excess nitrogen and phosphorus and some other pollutants from the water. So, just improving the water quality. Habitat Birds really love anything like this, but also all of the microbes in the water and all of the things that feed on that. So the whole kind of food chain of benefits, and not to mention all of the wonderful and well documented human co-benefits of plants in public space.
So, describe how they are constructed.
We've been well, I mean, if you Google floating islands or artificial wetlands or restoration techniques, there are a handful of products that you can buy that do this. Um, some of them are like coconut fiber logs that get staked down and planted. Some of them are made from a kind of a plastic felted cloth that then gets planted into or plugged into. There's bioplastic based meshes that get used, things like that. I think our approach is to try to use basically like local junk biomass to accomplish the same thing. Something that like, sources of biomass that are really cheap or even free or less than free. Sources of local biomass like forestry byproducts or waste invasive species like Phragmites. Um, we're experimenting with waste textiles and using those as the kind of substrate into which marsh restoration units can be grown um, without getting these, more expensive and higher carbon footprint products.
So people are basically weaving these by hand, aren't they?
We've developed a series of techniques of wrapping, lashing, weaving, layering that, yeah, experiment with how to combine these materials in simple ways to give them a little bit more structural stability while the plants are establishing themselves.
It sounds kind of fun. You get a lot of volunteers.
Um, We get some volunteers, but it's really hard work, actually. I mean, working outside a lot is very harsh. But I really love it. I mean, it's fun and rewarding work. And the people that tend to work with us enjoy that type of work. And you can tell very quickly when you get a volunteer if they are ready to go or not.
Yeah, you mentioned Phragmites. That's an invasive reed. Does it cut up your hands if you touch it without gloves?
Yes, if you're not careful. I have had some nasty cuts from Phragmites. But yeah, I mean, we have a whole method for working with it, cutting it down with a hedge trimmer and kind of baling it, bringing it up to our work area, and managing to, not get too cut up. It's also interesting. I mean, like it is an allergen, and so if you handle it too much, like on certain days, your skin will get a little irritated. So yeah, it's a little annoying, but it's kind of an amazing source of biomass because it grows so quickly in mostly fresh water or brackish conditions, and it's very woody and sticky, so that the wood fiber or the fibers are full of lignin and other like stronger fibers. So it has pretty good structural properties. So it's kind of the perfect biomass source for us for a lot of our prototypes.
How long do these structures stay floating?
Um, Well, we've done a lot of experiments with the floating units. We were adding foam to keep them afloat for a while, and I think what we've decided is that that foam is not really a very desirable material for us to have in any of our prototypes. So we've really, over the last 2.5 years, focused not on the floating prototypes, but we've really focused on shoreline-based coastal restoration techniques. So more just like growing new marshes and urban coastlines. Um, so yeah, Phragmites will float for something like 6 months until it gets saturated, and then it will be heavier than water.
Okay.
And that is a factor in our current research of creating restoration mats for urban coastlines because we want to use this material and actually we want it to sink. We don't want it to float away. Um, so yeah.
Sort of interrelated questions. I mean, first of all, to what degree were these wetlands originally before colonization, dredging, and everything like that? But second, I assume these waters are public property. How does one get permission to do this kind of work out there?
Yeah. I love this question, this series of questions together because um, yeah, throughout the history of colonization in so many urban harbors, marshes were flat, pretty flat, and they were therefore they were therefore convenient places for industrial development to happen. Yeah, you could drive steam steam engines or build tracks or build big warehouse buildings very easily. So you tend to get a lot of low-lying and flat um, you know, parcels at the coastline. So that just kind of covered up a lot of marshland. Um, and yeah, the other part of your question is the kind of contemporary politics of land ownership for coastal land. I mean, it's quite complicated, actually. It's very patchy, patchworky in terms of ownership. Um, and generally you have to get a permit to do anything. And generally the permits in Massachusetts are through the conservation commissions or the Environmental Protection Agency here. And it kind of varies from jurisdiction to jurisdiction. But I think the key question is that it's pretty hard to get permits for things that are bigger than an individual site.
Okay.
So that's a huge challenge for nature-based infrastructure in general, is that you really want solutions that can scale up really easily. I think that's our philosophy with this material approach, like using waste biomass to develop cheap, simple solutions for deploying big marsh restoration swaths on urban coastlines. But you really need in parallel to that, like a attitude towards permitting and permissions for building larger infrastructure across a patchwork of individually owned sites.
So, there's complicated legal jurisdictional questions that I'm not sure the listeners want us to go into, but let's talk about the attitude that people hold toward a coastline that makes this kind of work make sense. How, in other words, some people see a coastline as commercial value only. The priority is ship traffic. Some people see a goal of restoring everything to a pre-colonial state of nature, but as the sea level rises, I think we need to kind of approach it with a different set of values than either of those. So it's a rather vague question, but maybe just riff on that a little bit.
Yeah, no, that's another key question because, so many of those sites have current value and use value, let's say. And the people that have interests in those want to maintain them, and that makes sense. But if you look closely at urban coastlines, there are all kinds of funky, unique examples. There's a lot of pollution in these sites often, so there's restrictions on how they can be used. And actually, there's quite a lot of vacant land in so many urban harbors on the coastline. Um, And that's a kind of intersection of issues. Like, in many urban harbors, the water was filthy and noisy and polluted, and it was not a desirable place to be for so long. And that has somewhat changed in the last 40 or 50 years. In Boston, for example, the like major harbor cleanup in that time period. So I think people do see proximity to the water as a value, and they do understand the value of, something like a harbor walk or something like a green space such as a marsh or really, any kind of green space on the water. So I think there's understanding of the value there. Um, and I do think that the idea of nature-based infrastructure and coastal restoration and coastal protection is compatible with some of these tricky land use scenarios where there's like abandoned land, maybe it's toxic assets that nobody really wants to own or develop because they're just liabilities for certain types of pollution or whatever. These are perfect places to use for nature-based infrastructure that just become part of this sponge system to, yeah, to add more plants to the urban ecosystem, help the water quality, help habitat, etc.
So, how do you quantify and demonstrate the benefits both in terms of wave mitigation, water quality, species diversity? There's a lot there.
Yeah, yeah. We've done a lot of lab experiments and simulations about the first part of your question, the wave damping and coastal protection value of nature-based infrastructure. And that's starting to be pretty well documented. There's a body of scientific research that's experimental and has kind of like um, ground truth, friction factors from laboratory experiments that are keyed into simulation suites, things like that. So I think there's getting to be a good scientific consensus about the value of the protection value of plants in coastal systems. The other things are a little bit more tricky to quantify, especially in real situations, because if you do something in a lab, it's quite different in like in scale for one. Um, so, to have a measurable impact on the water quality of an entire urban harbor system, you would really need to have, you know, a swath of green infrastructure that is acres, right? Um, so that's a little bit more abstract, although there definitely is lots of scientific, citable um, factors for, quantities of nutrients removed by this amount of plants and things like that. But it's a little bit more difficult to kind of translate to real world
Right.
implementations.
So, I'm imagining most listeners to this are going to be fairly plugged into environmental matters, but just for listeners who are new to it, nutrient removal, is there too much nutrients going into the ocean or too little? Is
Yeah. Yeah, I mean, so nutrients is kind of scientific terminology that is a little misleading. We use that to mean, excess human waste through combined sewer overflow. So, I mean, in so many cities, the sewage system gets flooded with rainwater when there's a storm. And the simple solution to that has been to just like open up the valves and dump any excess sewage into the harbor. So that, people say like, sure, you can swim in the harbor, but not after the rainstorm, something
Right.
like that. So that just, cities produce so much waste in terms of, human sewage waste, but also just runoff, fertilizers, like all the extra plant matter that's decaying on the land ultimately washes into the water. So we call these nutrients, but they're just excess
Yeah.
of like nitrogen, phosphorus, and things that would grow plants, but in excess quantities can, can be toxic. So removing them, especially in like these really concentrated areas like urban harbors, is a key concern.
Are there dead zones and eutrophication anywhere in your area, or
Not really. I mean, a lot of the well, the Boston Harbor gets a huge tidal flow. The tidal range is, more than 10 feet every
wow.
day. So it really does get flushed pretty well. But it's pretty mucky, if you go out there and disturb some of the muck, you're like, whoa, this is gross stuff down here. So,
Yeah,
you know,
yeah.
so yeah.
Yeah, if you go a little further south, the Chesapeake, probably a little less tidal, they
Yeah.
have a dead zone. And there might, maybe the very bottom of the river would be anoxic naturally, but way too many nutrients going into it. So generally, wetland restoration is going to be very positive. Um, so how has the public reacted to these spaces? Do people kayak past them and see kayaks? Do they enjoy them? Do people notice?
Yeah, I mean, a lot of our prototypes, I mean, it's funny. You're like, oh, we're making our biggest prototype yet. It's like it's 10 feet by 5 feet. And when you put it on a coastline, it sort of disappears because of just the scale of the ocean. So that's one thing. Um, but I think in general, there is a culture of appreciation of green things, and but generally our work is recognized as valuable, and restoration is a valuable um, concern. Yeah, I mean, with a lot of our current living shoreline prototypes, they're a little bit odd looking. They sort of look like um, crescent shaped, or sort of like yeah, like lenticular bundles of Phragmites. And whenever we're down there checking the measurements of the plants, or taking photos or anything, people are always like, "Wait, so what is that?" I get a lot of questions, but people are very happy to hear that it's a restoration technique. So, I think there's appreciation.
Do these structures then tend to become, I mean, as the Phragmites breaks down, at the end of life, will this be much more likely to be a living marsh with marsh plants just kind of weaving themselves in and taking the place of that dead biomass?
Yeah, so that's
Yeah.
spot on. The concept with using a biomass-based substrate is that, like anything made of biomatter, it will degrade and just get eaten by microbes and fall apart over time. And the hope is that the root mass of the marsh grass plants will take over that structure over time. And it will, the great benefit of something bundled tightly is that it stays really rigid and firm, allowing those very sensitive and small roots to grow through. And as that continues to break down, hopefully the roots are well established enough so that they really take over the structural role there.
Yeah.
Um, that's the same general theory as a lot of the existing approaches to coastal restoration, like using coconut fiber logs. Like the theory is the same. It's just like a very dense, spongy, but strong mass that allows the plants to establish themselves. So I think that approach is pretty much industry standard, but we're just trying to use local biomass for the same purpose.
So one of my goals with this podcast is to inspire young people to look at careers in what would be considered green jobs. If that succeeds and someone's inspired listening to this, what would they study in school to design these kind of systems?
Yeah, and I mean, a great value of nature-based infrastructure, I would say, is that I mean, we call it nature-based infrastructure, but we could be more specific and just say a tree. There's great value to having a tree in a neighborhood. Um, but that tree isn't just a kind of like self-sustaining piece of nature. Like it requires a fiscal budget of maintenance of a couple different kinds. It needs to be considered in the longer term, how long that tree will last, like what happens when maybe it gets sick or needs to be cut down or falls down. So that I consider nature-based infrastructure for coastal environments to be similar. So you could consider all of the jobs that are possible with that in terms of maintenance, upkeep, implementation, um, management, you know, all kinds of things like that as viable career pathways. Now, a lot of those are not necessarily white collar jobs. Those are like hands-on blue collar, you know, kind of parks department or DPW or maintenance jobs that I think should be really valued by municipalities. And, you know, I always advocate for kind of a nature-based infrastructure core or kind of a crew that is an expert in coastal nature-based infrastructure and restoration that would be, a kind of a go-to group for this kind of work. So we have done some green job training and participated in training programs like that. And I'd like to do more because I think that's a key part of the question is like, who has the knowledge and expertise to maintain an artificial marsh in an urban coastline? Like, that's a pretty specific and unique body of knowledge. And yeah,
Yeah. We're coming up on our 30 minutes, so the last question is kind of a softball. The Secretary General of the UN, Antonio Gutierrez, just said last week that we have basically lost all hope of 1.5 degrees Celsius global warming. And that's sort of the threshold at which sea level rise was going to be minor. So, in a context of rising seas, is nature-based wetland restoration more important or less important?
yeah, yeah. I think it's actually significantly more important. And, if you think about a flood event where you all of a sudden you get salt water in parts of the city that have never seen that before,
Yeah,
so many of the of the plants that are there are going to die from the salt water. And so I think it's crucially important to develop human-made coastal salt tolerant um, restoration areas because they will survive flood events and they will thrive in the flood events actually. So
yeah,
I think we need to open a broader discussion about the ecological change that will happen when you get saltwater flood once or twice a year, or so I think coastal infrastructure is part of the equation there, and it's kind of an investment in ecological survival in a changed climate with increased storms and sea level rise.
here, here. How can people learn more about the Emerald Tutu project?
We spent a long time last winter working on a really thorough updated website. So it's emerald-tutu.com. You can dig in and learn about all of our research over the last like 5+ years. So yeah, and do drop us a line if you want to learn more.
And I will say that the visuals on that website are inspiring. So, yeah, by all means, check in. It's a vision for the future that it's both beautiful and practical. So, Gabe, thank you so much for speaking with us today. Really
Thanks so
appreciate it.
much for getting in touch and thanks for the great questions. Really appreciate it.
All right, thanks.
All right, take care. Have a good one.
My conception of this podcast is an archaeological search for fragments of the near future that we can observe in the present And I think that the Emerald Tutu project is a perfect example of this. Given the conditions of climate change, coastal defense is going to be part of our future. And this is a vision that's beautiful. It's inexpensive in terms of natural resources, and it produces wildlife habitat and almost certainly enhances fisheries and water quality. I think that this idea is going to spread far and wide. If you think that's a strong possibility as well, then help this podcast spread far and wide. Give it a rating, a review. Don't forget to smash that like and subscribe button. Thanks for listening.